Not buying it.
Is that?
Not buying it.
You're not buying it? Anyway, it's great to see you guys. Let's see, we came, CES, as you guys know, has changed a lot over the years. It used to start out being really about, quote, consumer electronics. And about 7 years ago or so, I think it's something like that, we invited Audi to CES for the very first time. And at the time, no German companies had ever come to CES. And they said, but this is consumer electronics. And what I told them was the car is the world's largest consumer electronics. And that although today it's a mechanical device and with these amazing engines and leather seats and industrial design, that in the future, the car will be packed with computing technology. It's going to be packed with software. It's going to be the ultimate consumer electronics device. And so I wish all of you guys had seen it, but it was plastered. Audi had come to CES for the very first time, Vegas for the very first time, and their executives came to Vegas for the very first time. It was just an amazing thing, and what they saw and the feedback they got was incredible. And it was at exactly the right time, I think. And since then, this has become practically an automotive show. And I think the simplicity of it is that consumer electronics and the fusing of computing technology into almost everything that we own, that particular trend is never going to stop. And so CES is getting larger and larger simply because computing technology is infusing into our lives more and more. Here at CES, we announced several things this week. I had a keynote. It was so jam-packed with stuff that we couldn't even include all of our important and very exciting gaming news. So I'm going to start with gaming first. As you know, GeForce is the world's largest game platform. It has 200 million active users, active gamers, and it is the #1 gaming platform in a whole lot of different countries, from China to Russia to Southeast Asia. And it's simply because GeForce, as you know, works incredibly well. Every single game works incredibly great on it. And the PC is an open, evolving, vibrant platform. It just gets better and better and better every day. It doesn't get better every 5 years. It gets better every single day. And when technology is moving the way it is, it stands to reason that a platform that can evolve every single day over the course of time would have a dramatic lead over the other platforms. Anything that has to take a giant step every 5 years. And that's the reason why GeForce today gives you the best possible gaming experience if that's what you like. It's also an open platform for different styles of play. As you guys know, a PC can support every single input and output peripheral. It doesn't matter what it is. Whether it's a gamepad or a keyboard or mouse or whatever it is, it's got such rich I/O. And because of where it sits on your desk, you can enjoy it in any possible way. As a result of that, all those different types of I/Os and different ways to engage the computer, there's a lot of different styles of play. You could use it for first-person shooters. You could use it for esports. You could use it for social. You could use your game to share your winning moments, to create art, to broadcast. Right? So the number of different ways that you can enjoy games on a PC, the styles of games, and how you can enjoy it, of course, continues to evolve. And now we know that gaming is not only a great game, it's a great sport. It's the largest sport. It's the largest sport because it could be any sport. It could be a football game one day. It could be a survivor game another day. PUBG, the latest game this last year. Incredible concept. You know, when you see a great idea, you see it and you go, oh gosh, why didn't I think of that? Right? It's one of those things you go, oh, come on, that is so obvious. Why didn't I think of that? So PUBG is one of those great game ideas. You know, it's like Survivor and Hunger Games into one. Just incredible idea. not only would it be a great game to play, it's also, just like Survivor and Hunger Games, it's a great game to watch. The number of people who watch PUBG is obviously very high. And so all of a sudden, a brand new genre came into gaming, and it of course did it on PC gaming. We announced several things. 10 new desktop PCs were created of all different sizes and shapes based around GeForce. 3 new Max-Q notebooks. We took energy efficiency and performance engineering to the extreme with Max-Q. From architecture to chip design to system design, voltage, power regulation design, thermal design, system design with our partners, software design. We took something that was already incredibly energy efficient and we squeezed it into a thin notebook. It was just, if you ever get to see it, I'm sure all of you have seen it, but Max-Q notebooks are just thrilling to look at. Just to imagine a computer that's 4 times the performance of a MacBook Pro, almost twice the performance of the highest performance game console. It fits on your hand like this in a little 20 millimeter notebook that weighs only 5 pounds. It's just craziness. And so we took our engineering skills to the limit and we delivered Max-Q. 3 new notebooks here at CES. And then we said, what else can we do to expand the reach of gaming and to take the experience to a new level? And we always thought that, man, wouldn't it be great if we could take PC gaming, which is already amazing, but put it on the one display that we always wish that it would be on, the largest display in your house. And what would we call the largest display in your house? Well, it's a BFG display. And so we called it BFGD, big format gaming display. All right? And so,
Yeah.
that's what it stands for. Yep, all along. And it never gets old. A big format.
You could have done bad with just big ass display.
Bad. Hey. All right, I'm going to keep that one. Nobody else heard it. Next time it comes back out, it was my idea. Thanks a lot, Jim. And so BFGD, big format gaming display. It's G-Sync, 120 hertz. And so there's literally no stutter. There's just no stutter. And so if it's running on 120 hertz, there's no stutter. Of course, you can't feel it. And if there's any changes in frame rate, G-Sync kicks in, there's no stutter. It's just silky smooth. Low latency, no stutter, high dynamic range, huge format. I mean, I just can't imagine a better way to game. And so the response from the reviewers, the response from the gamers that have seen it are just completely over the top. People just love it. You're engulfed in this silky smooth virtual world. It's just, life is good. Okay, big BFGD. All right, everybody go take a look at it if you haven't. And I think it's just a big thing. And then what we did was we also thought that every display and every monitor should be a smart display, should be a smart monitor. How can you possibly have something that is electronic, that isn't connected on the internet, that somehow isn't a streaming device? If it's a display, it should be a streaming device. So we took the Shield computer and we designed it right into the BFGD. Okay, and so now you take it out of the box, and it's a wonderful streamer. It's the best streamer on the planet. Supports Android TV, and if you would like to download games to play, boom, comes from the Android store, and if you would like to stream games from GeForce Now, our cloud gaming service with a supercomputer up in the cloud that processes all the game streams it to you, all you have to do is subscribe and enjoy games. Okay, so now you can enjoy games from the Android store, you can enjoy games from GeForce Now, and you can enjoy games from your PC. Basically enjoy games like crazy. And so we announced all that. We also added another platform to our GeForce Now. GeForce Now is our supercomputer at Nvidia with a whole bunch of GPUs in it, and it's running games and streaming the games to devices that don't have enough capability to play games natively. And the performance is fantastic. It's got our latest generation GPUs, you know, I don't ever know who's coming after me, so I got to look over my shoulder. So, you know, in my line of work, competitors are hunting me down all the time. So I got to be on my toes. You know, as Dean knows, they've been trying to hunt me down for 25 years. I'm fast on my feet. always in a position for the rapid escape. All right, so GeForce Now is our cloud gaming service, and we've been supporting the Mac. The response has been incredible. We've got a big long waiting list, and then recently we also opened it up for PC, and so we now support the Mac, we support the PC. Long term, what we would like to do is to be able to make it possible for you to have incredible gaming experience no matter what device you're on. Okay, it could be a phone, it could be a Chrome device, it could be anything. We just want you to be able to enjoy great games so long as you have a display. So the GeForce side did amazing work. And then we did one more thing, which was GeForce Experience. We updated GeForce Experience. As you guys know, GeForce Experience is our software platform that helps you enjoy games even more. And the first thing that it does is it automatically sets your computer for all of the various configurations and settings so that the moment you launch your game, you're already enjoying it. But we also make it possible for you to share so that you can capture that amazing moment. It's running in the background and it's storing video. It's recording your gameplay without affecting any of your performance. And the moment you have an amazing moment, you know that amazing moment has been captured for prosperity and to share with all of your friends. Okay, and so that's the ability to record and share. We also made it possible for you to turn video games into the world's first digital virtual camera, and so you can actually go into your video game and basically take amazing pictures of the scenery and the vista and maybe the moment and apply different effects to it. We call that Ansel. Okay, so we have Shadow Play, which is recording you all the time. We have Ansel, and then we have this new thing that we call Freestyle. And so now that you're playing your game, you could even apply special effects to it. And the reason for that is because our filters, our image processing is so powerful now that we can make it possible for you to enhance the imagery or even change the mood of that imagery, and maybe for Battlefield, move it into a look that's a little bit more vintage, a little bit more World War II. And so there's a lot of different ways that we can make it possible for you to enhance the imagery. We call that Freestyle, and the response for that is incredible. I think Freestyle it won Gadget of the Show, right? Freestyle won Gadget of CES. It's not even a gadget; it's software, and so it's so great. It's such a great gadget. It's great. It's such a great software. It became a great gadget, and so people love it. Go take a look at that. All right, so that's our gaming. That's our gaming. The team did a really great job. If you haven't had a chance to go to the booth, please do so. Go to the suite, please do so. Okay, so on the other side, we talked about the largest consumer electronics device, cars, and we announced several things. We announced that Xavier, the most complex SoC the world has ever made, 2,000 Nvidia engineers worked already for 3 years, and there's another year to go. Already for 3 years working on this incredible chip. This chip is the largest SoC the world's ever made, 9 billion transistors. Just think about all the processors that's inside. It's got an 8-core CPU, custom designed CPU, server class CPU. We call Carmel. Okay, ARM64. Level 1, Level 2, Level 3 cache, all ECC, all parity, designed for resilience. Server class CPU. It has the Volta GPU in it with the brand new Tensor Core instructions. It has a brand new deep learning accelerator to complement our GPU called DLA, the NVDLA, 10 teraflops of performance. It has a brand new computer vision processor called PVA so that we can process stereo disparity, the parallax of your displays to extract information like depth, stereo disparity, and optical flow, how pixels are moving from scene to scene to scene. We call that PVA. It has a brand new ISP, an image sensor processor, that allows us to process 1.5 gigapixels per second, so that all of the cameras and all of the sensors around your car can be in full high dynamic range. It has a brand new video processor that does encoding and decoding at a level that every single camera around your car could be processed and recorded like a black box while performing optical flow processing to it. Did I get them all? It's just crazy number of new processors. So from the entire processing pipeline of a self-driving car, from image processing, sensor calibration, perception, localization, and path planning, every single line of code of the entire self-driving car stack can run on Xavier. A one-chip self-driving car. We took all of the processing that was needed from our Drive PX2, which was a 4-chip solution, 4-chip Pascal solution, and we compressed it into one single chip Xavier. 9 billion transistors, 12 nanometer FinFET, silicon is back, it's working great, and I showed it driving a car on stage. Okay, we have 320 developers, from tier 1 OEMs to startups to taxi service companies to mapping companies to research organizations that are dying to get their hands on Xavier, so we'll start sampling it this month. So that was our first announcement. We also announced that the single most important feature of a self-driving car is safety. And safety is not just about trying really hard and being really careful. You have to design technology that makes it possible for the computer to be safe. And if you haven't had a chance to think about safety, this is really fun. This is a really fun area. And over the last couple, 2-3 years, I've dedicated myself to this field of safety, and I've learned a lot. And we changed the architecture and infused safety technology into our drive stack, from the architecture through the chip design, through all of the software, through all of the algorithms, into the system, into the cloud. And basically you have to solve 3 fundamental problems. In order to do safety, functional safety, you have to, number 1, have safety of the intended features. It's called SOTIF. Okay. Whatever you decide is the intended outcome, you have to somehow validate that you're designing something according to that. Number 2, it has to be resilient to hard failures, hard faults. If a wire were to break, if a chip wire were to be open circuited, if a solder joint were to wear out, a hard failure it has to be resilient to, and it has to be resilient to soft failures. It could be a noise glitch, it could be the temperature is too high, somehow the memory forgot a bit, maybe we got bombarded by an alpha particle somewhere, and all of a sudden we have a soft failure. These three fundamental failure types, functional failure type, otherwise known as system failure, systematic failure, hard failure, and a soft failure, the architecture in totality has to be able to deal with. The architecture in totality has to be able to deal with it. Okay, and so in the final analysis, what you're looking for is the ability to have redundancy and diversity. Everything you do has to have backup, and everything that you back up with has to be different than what you backed up originally. Okay, and so another way of saying it is I need to be able to do computer vision in multiple ways. I need to do localization in multiple ways. I need to be able to sense my environment in multiple ways. Multiple ways, not just many ways, not just more than one way. It has to be redundant and diverse. And so basically we're going to design future cars the way people design airplanes. Except we have to use so much technology and ingenuity to reduce its cost and its form factor. We can't afford to have a jet plane. And if we, of course, it'd be great if we did, it would be the brute force way, but unfortunately, the cost would be too high for society to bear. And so we have to apply all kinds of technology and innovation to do that. And so we announced that the Nvidia drive stack is going to be the world's first entire top-to-bottom functional safe drive stack, ISO 26262 with full functional safety, ASIL D quality. Okay, a big achievement. I'm really proud of it. We also talked about a method for achieving what is called SOTIF, which is safety of the intended functionality. And the way to do that is simulation. And as you guys know, the best way to know whether something works is to simulate it. We can drive thousands of miles per car, a week. And a fleet of cars would have hundreds of thousands of miles per week. But you guys know that society drives about trillions of miles per year. And so 15 trillion miles per year is how many miles we all drive around the world each year. Okay? And so we would like to have some percentage representation of that. The only way to really do that in the final analysis is through simulation. And so we created a parallel universe, an alternative universe world, a virtual reality world where we would have virtual reality cars driving in virtual reality cities, and each one of the cars would have an artificial intelligence, the entire stack of drive inside every single car. So our AI stack drive, called Drive, will be in all of these virtual reality cars, driving in virtual reality cities, running on a huge supercomputer with many versions of those virtual reality universes. Does that make sense? And so we're essentially going to have thousands of parallel universes where all these virtual reality cars are all driving around, and as a result, be able to test a lot more miles than in virtual reality than we could physically. Of course, we will, in addition, also drive the cars. So we have a large fleet of cars, and we're going to be doing our software that way as well. Okay, so we announced that it's called AutoSim, and it's a little bit like that movie Inception. We've got VR, we've got AR, we've got AI, and they're all kind of all embedded inside. It's kind of a bit of a brain teaser. But once you put on the head mount display, you'll feel exactly what it is. All of a sudden, using VR, we fused our world with that virtual world. We've now wormholed into that virtual world, and within that virtual world, you could see everything is in AI, and everything works just fine. Okay, so we announced that. We also announced several partnerships that we're going to be working with Uber to create their fleet of self-driving taxis. We announced that the hottest startup in self-driving cars today, Aurora, Chris Urmson's company, they partnered with Volkswagen VW and Hyundai to create self-driving cars, and that we're going to be partnering with Aurora to make that possible. We announced that we're partnering with VW to infuse AI into their next generation fleet of cars, and it's AI for self-driving. It's AI for the cockpit, Your future car will basically become an artificial intelligence agent. What else did I announce?
Can we ask questions?
Yeah, just 1 second. You know, I know what Dean wants to take control of the conversation. You know, I'm not going to let it happen until the end.
It's like, all right.
We announced
Ready to go
Mercedes.
now.
Yeah, we announced Mercedes yesterday. Yeah, we announced that Mercedes next generation fleet cars will have Nvidia AI in their digital cockpits. There was something else I announced on stage. Apparently it wasn't that important. I just feel badly if the partner. Okay, all right. Whoever is the partner, I forgot. I apologize. Let's have Dean go first. He's just dying to go.
Well, I guess early on you said CPUs are really not good for AI, right? And that the GPU was much better, is more naturally good at it. But it seems like with the latest design, it's a 9 billion transistor chip. Last year's was 15 billion. It almost seems like now you're almost getting away from the GPU in order to get grounds up AI designed chips. Is that sort of like a turning point in some ways that, first CPUs weren't that good at this, GPUs are better, but now basically you're going into AI chips that are more sort of fundamentally good at AI.
Mm-hmm. Yeah. So if you guys heard, Dean asked a really good question. His question is his. I didn't say it. He said it. He said it. His initial proposition was that CPUs are not good for AI, and I'm not going to disagree with you, Dean. That's what he said. You guys all heard it. All right? And so I'm not going to disagree with you. All right. And so who am I to disagree with you? I'll just go along with it. And so but I would agree with you that CPUs aren't good